Welcome to Adopting Zero Trust, or AZT, a podcast designed to provide context behind current challenges in the world of cybersecurity. Your hosts, Elliot Volkman and Neil Dennis, provide this platform to elevate important conversations, to drive action, and share the good word about the concept of zero trust. Now, on to your hosts.
All right, hello. Welcome back to Adopting Zero Trust, or AZT. I'm Elliot, your producer, and you may have forgotten about us because we haven't recorded in a little bit. Things have been crazy in life. Neil has changed jobs. He's been traveling, doing some stuff. I work at a company that has that logo on it if you see the video, but everyone listens to the audio, so you probably know. And I've dragged along a friend who I unfortunately terrorize at work, and he's going to be our guest of honor here to talk about something kind of cool. So I'm just going to read something to you all and tee this up, not our usual intro. So here's the deal. Picture this. You're chatting privately with an AI system about a sensitive topic, say a medical issue or a legal question. The entire conversation is encrypted, so no one can read your words. But someone watching your network traffic, maybe you're on public Wi-Fi or you have a compromised router, notices the rhythm and size of each data packet the AI sends back. From just those patterns, they can tell what topic you're talking about. That is the essence of WhisperLeak, the WhisperLeak discovery. Not breaking encryption, but learning from its echoes. JBO, did I get that right? Did I convert that into normal human language by chance?
You're asking me. I'm not sure if I'm a normal human, but generally, yes. It sounds good.
You're mostly normal, I'm pretty sure. Yeah, I don't know. You deal with me and can handle all the shenanigans at our job. So with that, let me introduce our guest. JBO, I believe, is the best way we're positioning you. You can also call him Jonathan. He is a principal security researcher. Oh yeah, principal security researcher, colloquially known as Defender Research. We also call it Microsoft Threat Intelligence. If you read our blog, he tends to have his hands in a lot of the interesting discoveries that we have. But we are talking about WhisperLeak, which we just recently, JBO just recently published, and it's been covered in Forbes and a few other places. That's the extent that I actually understand any of this stuff. So what did I miss, JBO? Can I explain that sort of correctly? You want to give a proper summary of what WhisperLeak is?
Yeah. So like you mentioned, basically the idea is not breaking encryption, but kind of concluding interesting data based on the packet sizes and timing of things that are sent back and forth. For instance, I'll give you an example from real life. Even if you send text that is full of gibberish to, let's say, Neil, right, that only both of you guys can actually decipher, if I intercept that in the middle, then I know that roughly, I can't know the contents, but I know exactly if you said just hi, or if you wrote a full essay, just based on the size, of course. Similarly, if I can measure how much time it takes for you guys to correspond, and then I can, for instance, know whether you respond quickly and talk about things, let's say, passionately, or things that are more boring, let's say, and then you respond very, very slowly. That's just an example from real life, as much as real life this is. And so basically that idea is not new, and it's a part of an entire class of issues and vulnerabilities that are called side channel attacks. Now, when people usually talk about side channel attacks, the things that come into mind are timing-based side channel attack, which WhisperLeak is, but also sometimes there are side channel attacks that reveal interesting parts based on power analysis, right? It's being done a lot in hardware hacking, for instance. In our case, we don't have access to the hardware, but we do have access, as I mentioned, to the packet sizes and the timing. And what we were basically, by the way, it's not just me. My partner in crime is Jeff McDonald. He's also a principal security researcher, in our case, also a security research lead in the same team that I'm part of. And he's an amazing data scientist. And together we basically figured that based on the data sizes and timings, we can train models to kind of conclude the conversation topics between, let's say, an LLM user and the LLM itself, even though, as you mentioned, everything is end-to-end encrypted. So that's the gist of it.
So before Neil comes in and pulls you off in that tangent, So if I maybe try to translate that to like human language, is that sort of like if you're having a conversation with him and maybe in an isolated booth, it's a window, but I can't hear you. Would it be like if I'm sort of reading your lips, or is it more like body gesture and trying to infer what you're communicating or trying to say?
It's a bit of the former and a lot of the latter, I think. There have been attacks in the past, and we actually quote that in the academic paper that we also released, that are actually able to extract the tokens. But the majority of, or I think vast majority even, I would say, of LLM vendors actually have countermeasures against those things. So you cannot get the individual tokens based on, let's say, the timing or data sizes. But because we get a lot of data, basically, we're able to infer exactly what you're talking about. So for instance, if I stand outside of a room and both of you guys are talking and I can't hear anything, but I see someone doing a gesture that looks like, I don't know, so you guys are talking about, I'm trying to think of something funny, but I can't. Let's say cars, right? Then I can infer with very good precision that you guys are talking about cars, or at least something big, for instance, rather than talking about something small or something that has nothing to do with something that drives on the road, for instance. And the more that I observe you guys talking, the more precision I actually get. This is something that we were actually able to quantify. I will mention two important aspects, like why LLMs? Why can't you actually use that against, anything that runs encrypted, which hopefully is everything on the internet. So there are actually two interesting aspects to this. One of them is that we measured and saw, and most LLMs actually use stream ciphers. Now, stream ciphers, basically, there are two types of symmetric ciphers. One of them is called block ciphers, and the other one is stream ciphers. Stream ciphers tend to basically conserve the size of the unencrypted, the plain text part. So if you write hello to Neil, let's say hello is 5 letters, then the stream cipher would hopefully be 5, or let's say like plus a constant, but something very similar. So that gives us more information, or gives someone, let's say, that runs a sidechain attack more information, versus a block size where basically, let's say, whatever you send Neil, it's like the ciphertext is always going to be a multiple of, let's say, 16 or something. The second part, which is the most interesting part, is that LLMs take a lot of time to generate contents and generate tokens. And because of that, and because humans actually don't want to wait, they send them chunk by chunk. And you can see this clearly if you ever interact with, I don't know, ChatGPT or whatever. You'll see that it looks like as if it's typing back. And it's not just to look cool, right? It actually does think, and it generates tokens and sends you whatever it can as soon as possible. And because it actually sends data in chunks, we're able to have this like timing issue that we're able to take advantage of. Otherwise, we just get one big block every time. So that's why LLMs are a bit unique here versus, any type of content which does not behave that way necessarily.
I know Elliot's waiting for me. I do have some things. So, curiosity questions before we go down the fact that I think this has been at least currently mitigated in the major LLMs that are out there. And we can talk about that towards the end, hopefully. But so the way this is structured, long and short, from my personal analogy here as a linguist, I'm going to use a really old school reference. For those who ever watched Stargate, I love Stargate. But as a linguist and as a block suite cipher, things like there's block cipher and stream cipher, stuff like that, it's almost character replacement 101 for obfuscation. It's not a true encryption schema. It's literally just a cipher schema in the sense, right? But is that encapsulated, or is it now going to be encapsulated into anything larger?
I would still trying to understand exactly the question.
So I apologize. My brain went on 3 different tangents all at once. So one of them being, so if we think about, it's a letter replacement, right? A equals C, or A equals Q, P, T, X, whatever. Pick a code base that you want to swipe through. Mm-hmm. And then most things from an encryption schema rely on key pairs to match up, right? That's basics. But the way that you're kind of describing it, when it's streaming the content out, you say, hello should be 5, maybe 6 characters static. Is it the same 5 characters during that session?
It's not. And that's something important. What you're describing, like basically, let's say monoalphabetic substitution cipher, is something that's known from like the old ages. It's not something that is considered secure today. And when I talk about the stream ciphers, I mean that basically the plain, it encrypts one character at a time, but it's not that the same character, for instance, hello has 2 consecutive L's. Those L's are not going to become the same character when encrypted. And in fact, the proper way to think about modern stream ciphers, which are, by the way, completely secure, it's not like the monoalphabetic substitution that you mentioned earlier, which is highly vulnerable to cryptographic attacks. Is the proper way to think about that is that it generates based on a certain password or secret that both sides actually share. There is a generation of a stream that we call a pseudo random stream. Imagine that it's an endless set of like letters. So A and then Z and then B and then I'm not very good at randomization, and then V and then W and then so on and so forth, right? And then L and then J and so on. And it could be repetitions as well. There's no problem. The issue is that if let's say Elliot and you are basically have agreed on that secret, then the 5th character in that pseudo random stream is going to be equal between you and Elliot. And the issue is that you can take that stream, do some manipulation with the actual plaintext and get something encrypted back, and Elliot can do the opposite thing. In computer science, and cryptography, we usually use an operation called XOR or exclusive OR to do that encryption, and it's perfectly safe. Modern stream ciphers, there are stream ciphers that have been known to be bad in the past, like RC4 is the one that always comes to mind. But the ciphers that are mostly used, and we mentioned that even in the paper, I think, is ChaCha20, which is like a well-known and good stream cipher, not proven to be vulnerable at this point to any of those cryptographic attacks. And AES GCM. AES, interestingly, is a block cipher, but there is a mode called GCM, which turns it into a stream cipher, and it's used everywhere. Both ChaCha and AES GCM like have good reputations. They're basically considered to be uncrackable, at least cryptographically. So there's nothing bad with those ciphers to begin with. Our attack does not rely on the fact that they're bad. And even if someone invents tomorrow a new stream cipher, new type that we've never heard of, it won't matter. The only thing that matters is the fact that there is a great correlation between the plain text length and the cipher text length. So if I see 5 letters between you and Elliot, I can guess that it's probably or hello or quack or whatever, 5 letters, and not is or encyclopedia or whatever, right? That's the main point and a part of what we've built actually.
Yeah. Thank you. No, we got there. I couldn't remember my cipher terms. As a guy who used to work in crypto, you think I'd be able to remember the terms better, but it's been a while. So no, I appreciate that additional explanation. So I wanted to iterate on that just because I want to make sure nobody comes out and goes, oh my God, did they break something? No, it's a literal inference model. They're just making educated guesses around what they think, which surprisingly gets you most of the way, apparently. So that's cool.
Yeah, in cryptography, like side channel attacks have been used quite a lot. Like, I don't know exactly who's listening to this, but let's say if someone wants to listen to something, to look at something interesting, then padding oracle attacks, for instance, that have been used in the past against the SSL are a type of a side channel attack in some cases, where basically you can infer whether the padding was good or not based on the timing. And we do something like that, but not to break the cryptography, but basically to get to infer something about the plaintext, just to put it out there.
Cool. I like it. So this is kind of fun because what I do remember from my Signals day, there's some programs out there for RF type related side channel attack constructs, and they still exist to this day, which is fun. But there was a program called Tempest in the government, which its whole purpose in life was to make sure that classified boxes were not close enough to unclassified boxes, which were not close enough to windows to where they could get the electronic emissions from like the VGA and DVI stuff, right?
Yeah, that
all those
refers
things, which
to what I mentioned about like and consumption, kind of like side channel analysis. It has been demonstrated in the academy for sure, and probably the government as well, that there is data leakage based on heat or whatever, that someone can infer what's going on. This is not what we do specifically, but
Yeah.
yes, those things do exist.
Well, so what was really fun with these were actually allowing you to catch the RF bleed out from the connectors into the monitor. And within a couple hundred yards with the right setup, you could get enough information to kind of see what was on the screen. So those were always fun. So
That's
I bring
scary.
that up. Yeah. And we can still do this today with those who are not hardcore into a laptop mode, funny enough. So if you're still using any kind of digital plug-in to the back of your, like on a monitor, even HDMI to a lesser extent, you can technically find ways to consume it. I say all that because looking at technologies as we grow forth and as we do new things, side channel attacks, there's always a wonderful world of finding net new things to do all that stuff. And whether it's inferring, which ultimately is what these RF issues are as well. We don't actually know what the image is. We have to do a lot of inference to piece it all back together, right? Just like you're talking about for this. So we fix one issue, and I think it's going to be fun because we're probably likely to find another one just as impactful or ease of access, which brings me to a question. Y'all, thankfully, I'll ding you a little bit. You released it on Friday, Elliot. However, it was something that y'all released on Friday with resolution attached and construct around resolution. So thank y'all. Everybody was bated breath waiting to see if they were going to have to fix anything themselves or call their CEO, I'm sure. But can we talk maybe a little bit to the mitigation strategy that's now implemented, if that's possible?
Yeah, that's a good segue. We in our paper, we actually, and when disclosing responsibly to everyone, first of all, I would like to mention that this is a statistical attack, and because of that, not every vendor was impacted the same way. Some were impacted more, some were impacted less, and those are based on sometimes coincidences, or sometimes maybe they thought about it ahead of time, even though I sometimes doubt it. It could be a happy accident, for instance, of someone doing something called token batching, right? When they batch several tokens in one go and send it. Or sometimes it could be the result of how the LLM server actually handles requests, and sometimes it can direct them somewhere near, somewhere far. So there are a lot of different reasons why some vendors might be more impacted than others, that just want to put it out there. So not every vendor has to fix immediately. We did recommend a bunch of fixes, including something that looks like a leaky bucket algorithm, where basically you programmatically allow only certain rates to be allowed, and because of that, it would be very hard to infer based on the timing. We also came up with a strategy of adding garbage value inside, which kind of hurts both the data sizes as well as the timing issues. So for instance, if you and Elliot are speaking and you want to send hello, you guys can agree that a certain letter, let's pick the letter Q because it's not used very often in the English language. So you can use hello, and between whenever you want to add garbage, you basically add Q. I can get a plain text word, a ciphertext word of 8 characters, and not know exactly if it's 8 or 7 or 6 or 5. If you do it well and you add your Qs in a sufficiently random manner. So we basically, and we also actually measured, like, to what extent will those mitigations actually help. And the vast majority of the vendors that we worked with, including Microsoft as well, by the way, who was also impacted, basically adopted the idea that the OpenAI now changed their actual API, and they added a new field called obfuscation, which is a true or false field. It's a Boolean field of whether to add those random Qs, let's say. It doesn't add literally Q, but you get the point. And I think Mistral has done something similar with a parameter called P, but it's the same idea. And those mitigate it to like enough that we hope that there is no single entity on the planet, hopefully, that can actually train a model like we did and basically infer like data from conversations with good accuracy.
So with that in mind, mitigations wise, do you think then computationally it's more of, it will become more of a resource necessity? Well, let me backstep. Do you think there's the possibility then with the right resources to move forward with compromising those changes and those obfuscations? So back on the whole, not to bring up quantum computing crap too much, but if somebody had enough tooling now, today, would they be able to go back and do that? I'm thinking more state-sponsored threats, right? Where we would probably want to look at any kind of models that are running in, gov cloud, government environments, things like that, and how we handle those when they go outbound, inbound, stuff like that.
Yeah. So putting the quantum computing idea aside for a sec, if you have, let's actually not do that. If you have a quantum computer, you'd be able to break TLS today as it is today. So you won't need to do anything and you're good or bad, depending on your point of view. The other aspect, putting the quantum computing aside, is that even we try to hint that in our blog post and in our paper that it takes quite a bit of training, because we actually built ML models to actually look at the data sizes and basically those sequences, the streaming sequences of data sizes separated by the timing differences of packets and infer data from those. It takes a lot of computation. I can say that the training that we did took many days, if not weeks actually, against every single model that we tested. And obviously also requires money because we actually have to pay someone to calculate those tokens, but that's a different aspect. We hinted in our papers that it would be someone with immense computational power, could be state-sponsored adversaries, like evil governments or whatever. We were able to do it in our proof of concept only against the one Boolean question, specifically about money laundering, whether someone is talking about money laundering or not. What we know, we don't just hypothesize, we actually know that is that just as easily as we've done it for that topic, one entity could train different models that would basically alert on other topics as well, depending on what they want to look at. And you can take it to several ideas on governments that want to suppress democracy, for instance, or certain human rights or whatever it is. So it is possible. It takes a lot of power and time and money, and practically we believe that it's a big enterprise for sure. It's something that governments can do, but probably not you or me, in our basements or something.
Yeah, that's good. Cost prohibitive for people who don't make any money for a living, but financially feasible for higher powers that be. So that actually led into my final question around that stuff. So thank you for answering before I asked. So I just iteration on that. The reason why it's important. So everybody always asks, obviously, what is it? Why is it bad? How do we fix it? And then who can take advantage of it before and after it's fixed if there's still opportunities, right? So working as an Intel analyst, quantifying threats, I have to be able to tell somebody as a boss, hey, Joe Schmo ransomware guy, don't worry about him. Even if he gets access to stuff, he's not going to have the capacity to do that, at least readily accessible capacity. But, if Johnny Q in China does, right, gets access, then maybe we have to worry a little bit more. So
one of the issues, though, for sidechain attacks, we also didn't mention, in our papers, we mentioned how to fix those things, right, and mitigations and what have you. We did not mention how to know whether you were impacted or not. One of the reasons for that is because it's practically impossible for you to know. Someone can sniff your network even today, save it, and then run that attack offline. So there is no way for anyone to actually defend themselves against that, besides, of course, being cautious with what you tell your favorite LLM. That's always a good thing to do anyway on a human level. But that's one of the issues with sidechain attacks. Just like you mentioned, the leakage from monitors, there's no way for someone that works on a monitor to actually do anything unless they put themselves in a Faraday cage or whatever. So same idea.
So, no, it's spot on. You jumped the gun on where I was going with that last piece. So capturing data and still having fun with it later. So I appreciate it. Yeah. That's kind of fun summarization for me. But maybe the last piece of this. So we talk about mitigations in certain services out there, certain LLMs that are available. If somebody wanted to check, right, to see what version, where would be a good place? Is this listed in the product, the research output, or should they just ping their happy LLMs and see what they've done?
That's a
Or would be their
difficult
best course of action.
Yeah, that's a difficult one. Generally, as far as we know, the chatbots that we mentioned, like if you just use your normal browser, they already add obfuscation, so you're fine. If you're using the APIs, then you should use only the OpenAI APIs that add the obfuscation parameter that I mentioned, or Mistral that uses the P parameter. And if those are accepted, I think that the response back should be something that looks like, hey, that like obfuscation is supported and you're good. So that's if you're actually coding or doing something with LLMs, then that's the proper way to do it. The other wink that we actually I was actually hoping that other people that might create their own like be an LLM vendor in the future is to think about those things. When you design a system, unlike memory corruption vulnerabilities or other things where it's certainly like someone's mistake. Here, it's not a mistake actually to try to return tokens as fast as possible or try to do it to use a streaming cipher. Those are not mistakes. They're only mistakes in a sense that you had to be aware of the idea that someone can have a sidechain attack, and because of that, the way that you program your program actually would defend against that. So it's proactively thinking about those things. So we hope that with our paper, it's going to influence like basically the industry as a whole to think about those ideas.
So I see a new potential market space for the FedGov side, Elliot. We have a zero trust LLM that, we don't need to worry about stream cipher so long as it comes back with the response reasonably timed, right? But we don't need people doing that stuff, don't have to wait or want to see stuff every 2 seconds. They're fine if you tell them come back in 5 minutes, we'll give you the whole chunk, right? And then we could start positioning that, and we could go sell to the FedGov space and outcompete certain other large scale paperclip oriented competitors and red, blue, and yellow. No, I'm just kidding. But with that being stated, in all seriousness on that, I do honestly think that because we have things and issues like this, we will obviously see vendors who operate things beyond the firewall logic for the FedGov servers, GovCloud, and have to implement things like that on purpose and then iterate, hey, this is not a 30-second response. This is a 3, 5, 10, 15-minute response, right? In chunk, not in bite sizes. So that'll be fun to see. One last thing, JBO. So any other sidebar things, any other pieces that you're working on in the future that we should be looking forward to? Or are you going to come back and break ChatGPT again anytime soon?
Traditionally, I've been working mostly on endpoint security. With the help of Elliot, I was able to publish even several pieces of my research as part of Microsoft research teams. And I intend to continue doing that. We have some interesting discoveries there. But, with Microsoft moving towards like security for AI and all that, I think there's going to be more ground to cover. The problem is that this space has a lot of, how should I say that nicely, a lot of moving pieces, right? And it's extremely difficult to actually cover a lot of ground because we don't even know where customers are going. We sometimes we can't really follow up, and it's extremely difficult to attack, let's say, or defend against certain attacks if they change every day or sometimes twice or 3 times a day. But I hypothesize that I'll probably come back here like in a few months and we can talk more about like doing something cool with AI.
Cool. Well, with that last nugget, as long as it's after Christmas, everybody will be happy.
Yeah, not on Fridays.
Not on Fridays and not on when's Christmas this year. I think Christmas is Thursday. So let's avoid that week, please. Do it on January 3rd or 4th, whatever that Monday is. That way people can deal with it hungover.
Yeah, not on Monday too. Yeah.
Well, and then, one little plug. So, I work at a vulnerability company now, and we have a lot of fun researchers. I know Microsoft and crew are obviously leaps and bounds scalability way beyond anything we're doing. But on the same vein, if there's ever a chance or a desire to plug away at, multiple threats, multiple exploit paths beyond just Microsoft and other tools, love to collaborate on stuff like that, obviously. My Intel brain, along with some of the researchers I have here, always happy to do that stuff, and happy to help monitor, track, and even look at infrastructure stuff too, beyond what's just in the Microsoft realm. So maybe that's a future story, and who knows where it goes from there. But I appreciate your time, JBO. Any other parting words before we run off?
No, thank you so much for having me. This has been a blast.
No problem. I've been very tame today, so I need to.
I appreciate that because
I heard rumors.
Very, very tame.
Hey, all I said was he is very Texan.
Yeah, that's the rumor that I heard.
I do have my deer rifle 3 feet away from me, and
So close.
I mean, well, I've got my self-defense here. I'm good. I got a giant spear sitting
Here
right
we
here
go.
next to me, so I'm a very happy fella.
Nice.
No, it's been appreciative, man. Thank you very much.
Awesome.
All
Thank you.
right. On that note, thank you for joining us to AZT, which will hopefully be back around. I don't know. Maybe we'll squeeze another episode in before the end of the year. Unlikely at this point. We'll see. JBO, thank you for joining us. If you want to learn more about WhisperLeak, I will put this in the show notes, but of course on our security blog, Microsoft security blog, just do a little search for that or type in WhisperLeak. A bunch of other people covered it. And then I believe we are going to have you chat with Sherrod for the Microsoft Threat Intelligence podcast as round 2. So, Neil, I treat us as a practice round, which is good because Sherrod is going to be a lot more meaner. Just kidding. We love Sherrod. Totally. Absolutely. All right. That's it. Thank you. Have a good year or something.
Yeah,
All right.
you
bye.
guys too.
Thank you for listening to AZT, an independent podcast. Your hosts have been Neil Dennis and Elliot Volkman. To learn more about the series, catch past episodes, or about Zero Trust, go to adoptingzerotrust.com. You can also subscribe to our newsletter for additional insights. Viewpoints expressed during this show do not reflect the brands or employers of our hosts or guests.